Hello everyone, welcome to my channel. So in this video we will discuss about manometers. So in this particular video I'll be explaining about simple manometers and I'll do another video on differential manometers. So before I move to manometers, I'll talk about the devices which are used for calculating fluid pressure at a point. So we have two devices, which is mechanical gauges and manometers, which are going to calculate the fluid pressure at a point. So first of all, coming to mechanical gauges. So mechanical gauges are devices which are used for measuring the pressure of fluid by balancing the fluid column with a spring or with a dead weight. Okay. And commonly used mechanical gauges are diaphragm pressure gauge, Borden tube pressure gauge, dead weight pressure gauge, and bellows pressure gauge. So these are the pictures of that. And coming to manometers. So manometers are also the devices which are used to calculate fluid pressure at a point, but by balancing the column of fluid by the same, that is the column will be open to the atmosphere or another column of the fluid. Okay, so manometers are classified into two types. We have simple manometers and differential manometers. As I've told in the definition, balancing the column of the fluid by the same means it is a simple manometer. Balancing the fluid column with another column of fluid means it is a differential manometer. So in our video, this video, we will discuss about simple manometers. In the next video we will see about differential manometers. Coming to the simple manometers, basically a simple manometer consists of a glass tube which is generally connected to the point where you want to calculate the pressure, and the other end will be open to the atmosphere. Remember, for all kind of simple manometers, one end of the manometer will be open to atmosphere and the other end will be connected to the point where the pressure has to be calculated. And we have three types of simple manometers, that is a piezometer, U-tube manometer, and single column manometer. Single column manometers are also called as micromanometers. Okay, and single column manometer is further classified into vertical single column and inclined single column, which we will see in our coming slides. Coming to the first one, which is a piezometer. Basically this is a diagram of a piezometer and it is a very simplest form of a manometer. So you can see one end of the manometer is connected to the point where pressure has to be calculated, that is at A, and the other end of the manometer is open to the atmosphere. So because of the pressure at point A, the liquid level has risen for a height of h. Therefore, the fluid pressure at A can be calculated by using the formula rho into G into h, where h is the height of rise of liquid in the manometer. Moving to the second one, which is U-tube manometer. So as the word says, the tube is bent in the form of U shape, alphabetical U shape, and using a U-tube manometer you can calculate both gauge pressure and vacuum pressure. So the definitions for gauge pressure and vacuum pressure are done in one of my videos, which is about absolute pressure, gauge pressure, and the pressure measuring system. You can check out that video in the fluid mechanics playlist. So you can see here in U-tube manometer we have a heavier liquid, which is the dark color shade. So generally a U-tube manometer consists of a heavy liquid, which is, I mean, heavy liquid means which is heavier than the liquid which is present in which is flowing in the pipe, or uh, the pressure of which liquid you want to calculate, that greater than that means heavier than that will be the liquid in the manometer. Okay, so as I've already told, it consists of a glass tube which is bent in U shape, where one end is connected to the point where you want to calculate the pressure and the other end is open to the atmosphere. So generally, I already told you, generally the tube is filled, the U tube is filled with a heavy liquid, uh, most of the cases mercury. It means that heavy liquid means this is the liquid who is having more specific gravity than this liquid. So coming to the calculation of gauge pressure first. So if you see here, AA is the reference line or the datum line, and B is the point where I have to calculate the pressure. So you can see the difference in pressure heads is H2, and you can see H1 is the uh, rise of the liquid, the lighter liquid H1. Okay, so generally for manometers what we do is we write the left side pressure and right side pressure, and for the equilibrium we equate both the pressures. Okay, and the basic formula for writing pressure is rho gh. So how much is the rise? that we will multiply. Okay, so now as I've told, AA is the datum line, the reference line, and B is the point where I have to calculate the pressure. So this is my goal of calculating P. So we have H1, which is height of the liquid above the datum line, that is a lighter liquid, and H2 is the height of the heavier liquid above the datum line. S1 is the specific gravity of the lighter liquid. So from specific gravity we can calculate density as S1 into 1000, and S2 S2 is the specific gravity of the heavy liquid, so therefore density of it will be S2 into 1000. So now we will see what is the left side pressure. So left side pressure, that is pressure above AA, the reference line, in the left side, means just observe only the left side, this side. You can see here there is only H1 rise, which is in the left side, that is the left column, and you have pressure which is acting at B. So pressure which is acting at B is P, so P plus, because of this H1 there is a pressure rise, so it becomes rho 1 G H1, so it's P plus rho 1 G H1. Similarly, if you see on the right hand side, directly you have H2, so the pressure created because of H2 is rho 2 G H2. Here the liquids are different, so rho 1 and rho 2 are different. So this is the left side pressure and this is the right side pressure, and for equilibrium we will equate two pressures, so equating both, P plus rho 1 G H1 is equal to rho 2 G H2. From here I need to calculate the value of P, so P will be, if I send this side, it becomes rho 2 G H2 minus rho 1 G H1. So this is how you need to calculate the pressure for a gauge pressure using YouTube manometer. Similarly, if you take vacuum pressure, so if you say vacuum pressure, there is no rise of liquid onto the right column because it's a vacuum pressure. Okay, and now you can see here you have H1, that is the height of lighter liquid, and you have H2, which is the height of the heavier liquid, both on one side. So from this diagram, can you tell what will be the pressure in the left column? It will be the summation of the pressure which is acting at point B, which is the value of P. So P plus, because of this H1, the pressure created is rho 1 G H1, and because of H2, the pressure created is rho 2 G H2. Therefore, the pressure on the left side will be P plus rho 1 G H1 plus rho 2 G H2. And what will be the pressure on the right column? There is no rise of fluid, so the pressure on the right column will be 0. So equating both the pressures, we get the value of P. So P will be minus of rho 2 G H2 plus rho 1 G H1. And because of this minus, you can understand it is a vacuum pressure. And the last one is single column manometer. So single column manometer is a extended version of YouTube manometer, what we have seen in our earlier slide, but here you have an extra part called as a reservoir. Okay, and the area of this reservoir will be almost 100 times greater than the area of the tube. Okay, so in single column manometers we have two types. One is vertical single column manometer and next one is inclined single column manometer. Let's see them. The first one is vertical single column manometer. So if you see here, as I've just told, we have a reservoir set up here. Okay, again you have a lighter liquid and you have a heavy liquid. It's just a modified version of a YouTube manometer. So here we have initially the datum was XX, but when I brought this setup, that is the heavy liquid containing YouTube, and when I connected this here, because of the pressure at A, there will be a little fall in the level of heavy liquid, and this fall which is happening here from XX to YY will be an increase in the H2. Means how much volume is coming down will be equal to that much volume going up. Similarly, amount of fall, that is by delta H, will be an increase here in H2. Okay, so now our reference line, so after falling of the heavy liquid, where is the liquid now stopped? At YY. So in this single column manometer, our datum line will be YY. XX is the datum line before connecting this YouTube setup, but after connecting the YouTube setup, YY will be the datum line. Okay, so yeah, that's what I've explained. So XX is the datum line uh, in the right limb when it is not connected to the pipe, and once it is connected to the pipe, due to the pressure at A, the heavy liquid will fall down from the reservoir level. by a value of delta H. So we will try to see what is the pressure at A. Okay, that is the value of P we will try to calculate. So before going to that, we will see some notations, that is delta H. So delta H, just now I told you, it is the fall of the heavy liquid in the reservoir. H2 is rise of the heavy liquid in the right limb, and H1 is the height of the lighter liquid from the center of the pipe to XX. Okay, and let's say PA is the pressure at A, what you want to calculate. Then capital A is the area of the reservoir, small a is the area of the right limb, that is the what is that, that is our cube. Okay, and S1 is the specific gravity of lighter liquid, this one. So density will be S1 into 1000. S2 is the specific gravity of the heavy liquid, so density will be S2 into 1000. Okay, so now our intention is to calculate the pressure at A, but before that we will do a small calculation. As I have told, once you connect this pipe, that is the pipe which is carrying heavy liquid, to this, what is happening? The level of lighter liquid is coming down by a value of delta H. Okay, so from XX to YY there is a drop of liquid. So this volume of liquid, how much it got displaced, will be equal to the volume which has gone up. So how can we write volume as area into one of the dimension? So what is the area of reservoir? I know area of the reservoir is capital A into by how much centimeter it has fallen down, or by how much length it has fallen down, delta H. So A into delta H should be equal to, I told, the volume which is falling coming down in the reservoir will be the volume which is coming up in the right column. So what is the area of the cube, small a, into what is the height, H2. So this volume is equal to this volume. So from here delta H will be equal to what, A into H2 by capital A. So keep this aside. Now moving on to the same concept of writing left side pressure and right side pressure. So if you see, considering YY as a datum, as I already told you, after the fluid has fallen down, the YY is the reference line. And if, let's take the left side pressure. So if you take the left side pressure, that is about YY. So we have uh, the lighter liquid here which is taking a height of H1, but our datum is YY, so we should not forget this delta H also. So it becomes PA, already pressure at A is PA plus rho 1 into G into, if it is directly H1 is measured from YY, we could have written H1, but there is delta H plus H1, so it becomes PA plus rho 1 into G into delta H plus H1, that's written here. And similarly, if you see the pressure on the right side, YY is our reference line, so directly it is rho 2 into G into, again this value should be added, delta H plus H2, that is the pressure in the right limb. So equate both the pressures and you simplify, you'll be asked for delta H. So delta H will be equal to, just now we have calculated the value of delta H in the previous slide here, which is A into H2 by A. So we will substitute that A into H2 by A. So it becomes PA as A into H2 by A into rho 2G minus rho 1G plus H2 rho 2G minus H1 rho 1G. But what is A? Area of the tube. What is capital A? Area of the reservoir. Let's say area of the tube is 1 mm square. So what does the area of the reservoir become? 100 mm square. I already told you area of the reservoir is 100 times the area of the tube. So 1 by 100, A by capital A means 1 by 100 is 0.01. So it's a very negligible value. I just took the example of 1 and 100. Okay, it can be any value. It becomes a negligible value. So if you try to ignore the value of this, finally our PA value comes out to be H2 rho 2G minus H1 rho 1G. Okay, so this formula is used for calculating the pressure in a single column manometer. And the next one is a inclined single column manometer. So in an inclined single column manometer, things are very similar. So it's actually here vertical. No, it's not vertical, it's actually inclined. Okay, so inclined single column manometer is very similar to the earlier one what we have seen, but the thing is here you can see the right limb was vertical in the earlier case, now it is inclined by an angle of theta. Okay, and because of the inclination this rise will be more. And to calculate the pressure here is very simple and very easy, just like the earlier case. If you remember the earlier formula of vertical single column manometer, the same will be here also, but in the place of H2 we will have a small difference. So L is the length of the liquid moved in the right limb, okay, and theta is the inclination of the right limb with the horizontal. H2 is vertical rise actually, so we are going to convert this inclined rise into a vertical rise, so which is simply equal to L into sine theta. Okay, so we already got the formula from the vertical single column manometers, H2 rho 2 G minus H1 rho 1 G. Just in the place of H2 you need to substitute L sine theta. So PA becomes, so yeah, it's here L into sine theta into rho 2 G minus H1 rho 1 G. So if you are able to remember the derivation for vertical single column manometer, inclined is very easy. Just in the place of H2 substitute L sine theta. So this is how you need to calculate the pressure using manometers. The concept is very simple. Write the pressure at the left limb, write the pressure at the right limb, and equate both. Okay. And basic formula for writing the pressures either in the left limb or right limb is rho into G into rise of the liquid. If it is H1, H1, if it is H2, H2. So that's it for this video. Wait for differential manometers in the upcoming video. Thank you so much for watching.